of a circle. If you look at this picture over here on the left, we got the center of the circle at C, and we draw this angle. If this angle is centered, or if its vertex is at the center, we call that a central angle. And that as we draw those out, those sides, they intersect the circle at A and B. The portion of the circle that's contained between those, it was in here in red, but that's an arc. Since it's less than 180 degrees, we call it a minor arc. And you can see how we label it here. It starts at A and ends at B, and we put the little arc symbol above it. We could have also called it arc BA. But arc BA or AB is the portion of the circle starting at A, ending at B. If we want to go the long way around, if I want to start at A but travel counterclockwise, once again, it starts at A and it ends at B, but I need to differentiate between the two. So if I went the long way around, it also passed through point D over here. So I include that as the middle letter. I started at A, I ended at B, but I passed through D in the middle, so arc ADB. Since it's a bigger portion of the circle, it's bigger than half of the circle, we call it a major arc. So major arc ADB is how we would write that. The relationship between a minor arc and a major arc is that they together make up an entire circle. Therefore, they add up to 360 degrees. So if you know the minor arc, then you can subtract it from 360 to get the major arc. So if we look at this picture over here on the right, you'll see we have a central angle. Its central angle is 50 degrees. Well, a central angle and the arc that it creates have the same measure. So if the central angle is 50 degrees, you'll notice that the measure of that arc is also 50 degrees. So then if I want to go the other way around, the long way around, the major arc, ADB, it's the remainder of the circle. So I take the full 360, subtract away that 50, leaving me with 310 degrees for the measure of the major arc. Now, on our notes, it doesn't talk much more about major and minor arc, and it doesn't bring up half of a circle. If it is, what if it's exactly 180 degrees? If it's exactly 180, it's not a major arc, nor is it a minor arc. But you should already be familiar with that term. Probably in kindergarten or when younger, elementary ages, you were told to sit in a semicircle. A semicircle is half of a circle, so that's when it is 180 degrees. So if the measure is 180 degrees, know that it's a semicircle. Minor arc is less than 180 degrees. Major arc, greater than. And it won't be larger than 360. So now this next section, this example, they give us a picture. They want us to find the measure of these arcs. First arc RS. So we start at R, we travel to S. Notice that that arc is created by this angle RPS. It's a central angle because the vertex is at the center. It's 110 degrees, so the arc has the same measure. So that's 110 degree arc. That is less than less than 180. They're not asking you to tell if it's major, minor, or a semicircle, but if you might be asked, you will be asked that on the assignment at times. So you would have been able to say that it is a minor arc. Next, it talks about RTS. So we start at R, we end at S, but we have to go through T along the way. So we have to go the long way around. That looks like that's the rest of the circle. So we could just subtract the 110 from 360, giving us 250 degrees. That is more than 180, therefore it was a major arc. And then lastly, RST. So that begins at R, travels through S on the way over to T. We need to know how many degrees that is. Well, notice up in the instructions, they tell us that segment RT is a diameter, and RT hits both endpoints. So, and we know a diameter is really going to cut the arc in half, so it cuts the circle in half. So that's half of a circle. So it's a semicircle, 180 degrees. This next example, if you look at the printed off sheet, it's kind of hard to read and you don't see those divisions. But if you look up here, this is more clear because it's color coded, so you can see it a little bit better here. Notice, okay, they tell us a recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or other person. The results are shown in the circle graph. Find the indicated arc measures. Notice they've already split each category into degrees. So it's not saying percents. They don't add 100%, but they're telling us how many degrees in each section. So those should total to 360. So we need to find the measure of arc AC. So start at A, travel to C. It's the short way because it's only 2 letters. So if we go from A to C, we covered 2 different sections. We first had 29 degrees, then we had 108 degrees. So we just need to add together 108 and 29, giving us 137 degrees. So from A to C, we passed the 29 and the 108, so we just added those together. Next, for B, we start at A, we end at D, and we have to travel through C on the way. So it's the long way around from A to C. So I traveled 29 degrees plus 108 degrees, so it was a total of 137 like we had just done, but then we get to add 83 to that. So that would be, what, 220 degrees? Next, they want us to start at A, through D on the way to C. So we stop at C, but we travel through D on the way. So that's 79 plus 61 plus 83. 79 plus 61 is 140. So then we get 223 degrees when we add all of those together. So then lastly, EBD, we start at E, travel through B on the way to D, long way around. So we have almost an entire circle, but we're 61 degrees shy. You could add 79 plus 29 plus 108 plus 83 to get your answer, or you can say it's everything except for 61. So it's 360 degrees minus 61, leaving you at 299 degrees. You can take 360 minus the 61, or you could have said 79 plus 29 plus 108 plus 83. Both of those would give you the same answer. Next, we talk about congruent circles, which leads us then to being able to talk about congruent arcs. So first of all, congruent circles are 2 circles that have the same radius. If 2 circles have different radii, then they're not going to be congruent to one another. But if they have the same radius, then we know that they're the same size. Congruent arcs, 2 things have to be true for arcs to be congruent. They do have to have the same measure, that's part of it, but they have to have more than just that. They have to either be on the same circle, or if they're on 2 different circles, the circles have to at least be the same size. They have to be congruent angles, or congruent arcs, congruent circles, sorry. So they're arcs of the same circle or congruent circles. So if we look at these pictures down below, and you look at A, they're asking us about arc CD. So right here, we see that arc CD would have a 45-degree measure because the central angle is 45. And then they ask us about EF. Well, that has a central angle of 45, so it's a 45-degree arc as well. The 2 arcs do have the same measure. They're both 45, and they're on the same circle. So we would say that, yes, they are congruent. It tells us to explain. We just say same measure and circle. I'm going to run out of time here pretty quick. But if you look at this next one, CD and EF, they both have 110-degree measures, 110-degree central angles, but they're on different size of circles. That makes it not congruent because the circles aren't the same size. Over here, C, D, E, F. They're from